And it's a really difficult discussion to jump into, so I'm going to go around a couple times from big to small and back again. Again, ask questions when you have them. The first big jump is to look at dimensional relationships. You need to be able to put a lot of the unknowns today someplace. And dimensions have been abused over the last 20 years primarily by string theorists. Coming up with all the different, 12 different dimensions and all the relationships. And there's a new dimension for every problem they have, scientific problem they need to solve, and so forth. So go back and really look at what you know about dimensions. And we can see 4 of them. 3 of them probably is more accurate. But you have a 0 dimension, which is a single point. The first dimension is a line, which is an infinite number of points extending in both directions. When you introduce the concept of a line, you introduce units of measurement like inches and centimeters and miles and light years and so forth. You've changed the dynamics of being able to identify a single point in space to something that actually has some substance. You go to the second dimension, and you end up with a plane. We did this last time, and I couldn't draw the next one. Tim had to come up and do it for me, but you end up with a plane. You have basically relaxed one of the laws of nature. You have allowed for additional lines, and a plane is simply an infinite number of lines running in an infinite number of directions, all combined. The second dimension, the first dimension, is a completely self-contained subset of the second dimension. And this continues. You add the third dimension, which is simply the addition of one. You guys have all seen this done before, right? I have a real hard. You add one more variable, which basically is the z-axis. You add depth. The third dimension, our universe, is a result of relaxing one law of nature from the second dimension, and that is adding the z-axis in depth. The third dimension is simply an infinite accumulation of planes heading in all different directions. The second dimension is a completely self-contained subset of the third dimension with a simple spatial law of nature relaxed. Now, dimensional relativity is important. You cannot, at least I can't, imagine going from now, of course, there's no life in the first dimension, but going from first dimension to second dimension, all the possibilities that arise when you do that, or the second to third. Well, the concept of going from the third to the next dimension is just as daunting. Yes?
Isn't the fourth dimension time?
One of the variables that are relaxed in the fourth dimension is time.
Right, so like, don't we live in a three-dimensional subset of
Yes.
four-dimensional universe?
The fourth dimension is actually not a universe. Universe is a spatial description, but we live in a subset of the fourth dimension, yes. Completely self-contained subset of the fourth dimension, which is important in the progression. So going from the third to the fourth dimension, the next dimension is, so another thing that I assumed here, a large assumption, is that there is life after death. Something does happen to you. You don't just peter out. This all does feed back to some of the logic here in a second. But from the third to the fourth dimension is the same type of step as from the second to the third and the first to the second. Okay? What do we know about the fourth dimension? And again, some assumptions. One is time is not linear. A lot of the really difficult questions we have that have forced us off into the scientific weeds are based on trying to figure out the beginning or the end, either the universe or of the linear time. We are restricted to an organic structure. Our physical being, which we're dependent upon here, has a lifetime, and we are restricted into linear time. Relaxing linear time changes things dramatically. The other thing that is released from this dimension is that life is not restricted to an organic structure, which we're not going to talk much about here today. But time is basically the major variable that's eliminated from the third dimension going to the fourth dimension. So what the fourth dimension is, and the third dimension is a completely contained subset of that, is the same as the third dimension. It is completely made up of energy. The difference between the third dimension and the fourth dimension is the fourth dimension is energy without mass. It has no mass. And there's significant crossovers of that into our third dimension that all of us experience. But there are two different types of energy in the fourth dimension. One is pure energy, which is ether. It is the energy that occupies empty space. And the second is organized energy, which, for better name, I call the universal consciousness, and that's life in the fourth dimension. An example of energy, organized energy without mass in the third dimension. You have imaginations. You can create things in your mind. You have visions, you've got memories. You can do things that have that have substance, they're real, but they have zero mass. There are a lot of people who have had more extraordinary experiences, which is they've had near-death experiences, and they've gone on to really interesting things. They think they've seen God, and they've seen love, and so forth. They get brought back in here. There are people with extrasensory perception. There are lots of different examples of massless energy, organized massless energy being used. What we're going to talk about here today is more the interaction of the pure energy with physical matter. So the big jump in this discussion, if you leave life completely out of it, is that the universe, our physical universe, floats in a giant ocean of energy. And then defining the energy properly gets us to what some of the basic questions, like what powers the atom.